So I am Cyrene Calvelo, and today I will be discussing to you, and I will give a real life application and its importance as an engineer. Overview. Time and money are the essence of construction. Thus, in every project, it is important that there is effective time management and project scheduling in order for us to save time and money. Project scheduling should not only be implemented when problems arise in a project. Project scheduling should be implemented from the start up to the completion of your project. Project details. So guys, I'm gonna share to you my project a few years back. So this is the drawing site development plan of reservoir and pump house. The dimensions of the water reservoir is 3.5 by 3.5 by 4.08 meters. After the ground reservoir was constructed, we immediately performed the leak test. This is important to ensure that the reservoir is watertight or free from leaks. Okay, so at this point, we do not know how much time it would take for the water tank to be completely filled with water. So we will use related rates in order to solve for that time. In the next slide, I have come up with a problem which will help us solve the needed time for the water tank to be filled completely with water. So find the rate at which the height of water rises if pump is adding water 60 gallons per minute. So we know the volume of the tank, which is 50 cubic meter. So for conversion, 60 gallons per minute is equal to 0.0757 cubic meter per minute. And then we convert that to hour. Volume is equal to 3.5 by 3.5 meters times height of the water. Volume is now 12.25 times height. So dV over dt is equal to 12.25 dH over dt, where dV over dt is change in volume with respect to time, and dH over dt is change in height with respect to time. dH over dt is now equal to 0.37078 meters per hour. So since we have this equation now, we need to get the time, 2.697 hours per minute multiplied to the height of the tank. We have this, which is equal to 4.08 meters. So now we have the final answer, which is 11 hours. So this is after 11 hours where we have filled up the tank completely with water. So since we have identified the leaks, the next thing to do is we need to drain the water tank so that we can rectify the leaks. We will use a submersible pump and hose. There is also a drain pipe at the bottom of the tank, so we will open the valve. So it will help with the draining of the water. After that, both the exterior and the interior walls should be dried, and it will be cleaned before we apply the cementitious materials and other materials needed for the rectification and waterproofing. So the interior walls of the tank will also be dried using a heater. Okay, so before I go to the next slide, before I show you the computation, I will be discussing to you first why it is important to know how much time it would take to drain the reservoir completely. So the first reason is procurement sequence. As I mentioned earlier, scheduling is very important in a project. It will ensure the timely arrival of materials needed for the rectification of the leak. In some parts of the Philippines, some materials are not readily available. So we need to order it ahead of time and wait for the delivery. Moving on, so the second reason is timely completion. In order for us to meet the proposed date of completion of the project, placement of manpower is needed while other parallel activities are still ongoing. So as I've said earlier, aside from the water tank, there is a pump house being constructed. As a project supervisor, I need to know the exact time the water tank will be completely drained, so I can get a certain number of manpower or laborers from the pump house activity or construction, and I will delegate them to the rectification of the leaks. So the last reason is weather. So Philippines being a tropical country, we are prone to experiencing rainfall all throughout the year, especially this project is done in the month of July, which is one of the wettest months in the Philippines. So we needed to know how much time it would take the water tank to drain so that we could immediately proceed with the rectification. We need to schedule the rectification on a sunny day so that the water plugging compound and the waterproofing materials would dry properly without the hindrance of the rain. So let's get to the computation. So find the rate at which the height of water decreases if submersible pump with hose is draining water at 25 GPM or gallons per minute, and the drain pipe at the bottom is draining at 12 gallons per minute. So the same as the previous example, the equations are the same, except that for dV over dt, we added 5.676 from the pump and 2.724 from the pipe. So here we got the total time to drain, which is 6 hours. After 6 hours, we proceeded with the rectification. So you can see it in the pictures here in the slides. So it's the rectification of the exterior walls, and the next slide is the repair of the interior walls. So that's it. That's the last slide of my presentation. So I know that we are all engineers or aspiring to be engineers or math enthusiasts, and I hope that I showed you a good example of real life application of related rates, calculus, and mathematics. And I hope that you learned from me. That's all. Bye.